Good morning, everyone. How are you doing? I am Mr. Ish. Thank you for joining me. A triangle representation here, two triangles right here. We have some values which are provided. X is equal to 35 degrees. We have QRST and the segment QR is equal to 5. We have to find the area of a triangle RST. And the question is how you would go about determining this area triangle RST. It should not be excessively hard question by any means. If x is equal to 35, you can start plugging in these items. This right here is 35. And then these right here are 70 because they're twice the x, so that's not too hard right there. 70, and then this right here will be 70 as well. You can determine all the other angles utilizing what you know. You have 70, 70, this is isosceles triangle, this right here will be 40 because these three will add up to 180. If this right here is 70, this right here must be 110. If this is 110, then that's 35, then that must be 35 as well. So you have two isosceles triangles. Now, QR right here, this segment is equal to 5. But you can start filling in the other segments as well. This angle 35 opposes a side which is 5. Likewise, the other angle in the same triangle which has an equal angle would also oppose a side of 5. This right here would be side of 5. This TR, segment TR would be equal to 5. And nothing here is drawn to scale, so don't get fooled by the image. Now we have TR is equal to 5. If TR is equal to 5 and it's opposing this angle 70, and you have a 5 over here, the opposing angle 70, which is of the same angle dimension, must also oppose a side which is equal. Therefore TS must be equal to 5. So we've determined all of this. Now we have to determine the area of this triangle RST, and how can you do it? What we can do is recreate this triangle up over here and then fill in the items we know. We have a 70 here, we have a 70 here, we've determined this to be 5, we've determined this to be 5, we have a 40 over here. You can determine this because you need to have half base and height for this triangle, which is RST. We can determine this side right over here by using the law of cosines. This angle is opposing a side for which you don't know. We'll call this side B. We'll have B square is equal to the opposing side squares, other sides, 25 plus 25 minus 2 AC cosine 40. 2 times 5 times 5 and then cosine 40. And you would just have to plug away and solve for that angle 5, and we will do it. I'll work from right over here in this direction. I have 40 cosine, which I'll multiply with 5 and then another 5 and then minus 2. And I solve this part right here, and then I'll add it to 50 plus 50 and we'll square root it. I get 3.42. So this right here, this dimension here, B, is equal to 3.42. Now we have to determine the height, and you can do that. Just make this into a right triangle and you separate it into right triangles and use sine. Sine of this 70 degrees is equal to this height over the hypotenuse, which is 5, and then height is equal to 5 times sine 70. Not too bad. 70 sine times 5, I get 4.698, which I'll just round to 4.7. 4.7. So I've gone 4.7 height, I've gone this, I have to just plug it in over here. I'll do 3.42 times 4.7 divided by 2, and that'll give me the area of this triangle RST, and let's do it. 4.7 times 3.42 divided by 2, and I get 8.037, which I'll round to 8.04. And the area of that triangle will be 8.04 units squared, and the question has been solved. It basically required you to recognize that you have isosceles triangles from which you can determine all of these missing angles. Then from the angles utilizing just a single side, you can determine everything else using the properties of isosceles triangles, and of course using this law of cosines. We know this right here is a 5, this right here is a 5, that right there is a 5. We know this right here is a 3.42, which we've determined from right here. And then if this is 5, this is 5, you can easily determine this using law of cosines. You have an angle and you have two sides and you can determine that, but you don't need to. Don't get fooled by the fact that here 35 degrees is opposing a side 5, but here 70 degrees is opposing a side of similar and equal dimension. How is it possible that one smaller angle is opposing a side where the larger angle is opposing a side of the same dimension, because that rule only applies to angles and sides of the same triangle. Here you have two different triangles, one of which has an obtuse angle, the other one has acute angle, so that works through. Here you have a smaller angle opposing a side of a given dimension which is opposed by a larger angle from another triangle. So you have an independence over here with regards to this shared side and the angles that oppose it. But that's it for this particular video. We've determined this, and this should be a good answer. And thank you for watching. Have a good day. Bye.